Okay. Chapter 7.3, we're still dealing with exponents. Specifically today we're looking at rational exponents, which simply means that our exponents can be fractions now, right? We've not dealt with that yet, but we've talked about it a little bit. Exponents can be fractions. So specifically today we're looking at two objectives: evaluating and rewriting expressions that have rational exponents. And we'll also be solving equations that have expressions with rational exponents. So evaluating, rewriting, solving, these are all things that we'll look at today. Okay, so here's our first rule, kind of thing to be aware of here. And here's what it says. So for any non-negative real number, now that simply means that any number that's not a negative number, right? So we don't want to put negative numbers under our radical. We don't want to put non-real numbers under a radical. So we're talking about positive and negative whole numbers, positive and negative fractions. Pretty much anything that we've dealt with up to this point can go under the radical. So here's what it says. If I take a base and raise it to the 1/2 power, that is equal to taking the square root of that number. Okay, so we've done square roots before, we've done exponents before. 16 to the 1/2 simply means that I'm taking the square root of 16. Okay, 38 to the 1/2 power simply means I'm taking the square root of 38. Now, for where we are now, if it is a root that we can evaluate, we'll simplify. We'll go ahead and evaluate that root. Square root of 16, we know. Square root of 16 is 4. Square root of 38, we're not ready to simplify that one yet, but that's something that we will be able to do as we move on. So this first rule simply says that if I have an exponent of 1/2, that is equivalent to putting that base under the radical, under the square root. Now I do want to point something out right here real quick, and we'll see it on the next rule, I believe, but there is a 2 that's right there that we don't have to see. So just like here, there's an x to the first, except we don't have to see that x to the first. So the smallest root that we take is the second root, so we don't have to see that 2. Anything higher than that we'll have to see and evaluate it, but with a radical that doesn't have an index out here, right, we know that that's a 2. We know that we're taking a square root. All right, here's your next rule. The nth root, okay? So we want to make sure that you understand that there is a connection between a number raised to a power and its answer, and also the root of that number and getting us back to the base. Okay, so here we go. And it says right here, a to the n equals b. So that means that the nth root of b gets us back to a. So here's how that works number-wise. So 2 to the 4th is 16, right? 2 times 2 times 2 times 2 equals 16. That means that the 4th root of 16 is 2. Okay, so a power and its root kind of undo each other. That's the inverse operation. Powers and roots undo each other. So if we had, say, 3 cubed equals 27, so we know that the cube root of 27 is 3. Okay, so we can take the nth root, and what that does is it gets us back to the base that would have that same exponent. Okay, one more rule here. So a fractional exponent other than 1/2, right? So we kind of did one earlier where we had 9 to the 1/2 power, and that meant the square root of 9. This property though says that works for any number that's the bottom of a fraction, right? So in other words, 27 to the 1/3 power can be rewritten as the cube root of 27. And then this is one that we could go ahead and evaluate, and we would get 3. Okay, 32 to the 1/5 power is the 5th root of 32. And you've not played with this enough yet to know this, but that is 2. Okay, now I'm going to come up here real quick and show you why. Because 2 to the 5th equals 32, and you've not played with that enough yet to know, but that's why. So so there you go. Fractional exponents, we rewrite them in radical form. Okay, so here we go. And this screen is all about just making sure we understand how to go back and forth between the two notations. So 25 to the 1/2 power means the square root of 25. The cube root of 27 could also be written as 27 to the 1/3. Right? So just being able to go back and forth. 125 to the 1/3 is the cube root of 25. Now we're just going back and forth between notations. We haven't solved anything. We haven't evaluated anything yet. We're just going back and forth between the rational exponent notation and the radical notation. Square root of 16 is the same thing as 16 to the 1/2. 32 to the 1/5. The 4th root of 256. Okay, so this is just making sure that we know how to go back and forth between notations. Now, in any of these forms, whether it be the radical or the rational exponent notation, like all of these are expressions that we can actually simplify, evaluate. The square root of 25 is 5. The cube root of 27 is 3. The cube root of 125 is 5. Okay, because 5 cubed is 125, right? So then we can take the cube root of 125 and get back to 5. Okay. The square root of 16 is 4. The 5th root of 32 is 2. Right? All of these are powers and roots that we will need to be comfortable with. Right? Now here's another rule, and this is where our exponent changes. Notice that we don't have a 1 on top of our exponent anymore. We've just got some random other number. Okay, and as long as it is a positive real number, and as long as the fraction is actually comprised of integers, in other words, it's an actual fraction, okay, then we can rewrite and move things around this way. Now I want to show this to you. I'm going to pull this down here, b to the m over n. Okay, the top number is the power, and the bottom number is the root. And I kind of think about it like if that's the earth, powers are above the earth and roots are below the earth. So that's kind of how I remember powers and roots. But the power is like what we typically would call the exponent. The root is the radical. Okay, so we can rewrite using the root and the radical. So here's the example they give us. 8 to the 2/3. Okay, so the bottom is the root. So we take the cube root of 8, but then that whole thing is raised to the power of 2. And then all of this could be evaluated. All right, the cube root of 8 is 2, and then 2 squared is 4. All right, so we can do, say, 32 to the 2/5 power. Okay, if we wanted to rewrite that, that is the 5th root of 32. And then that whole thing would be squared. And then we evaluate, right? Inside to out, order of operations. The 5th root of 32 is 2, but it's still squared, and so our final answer would be 4. Okay, we could do, let's go 27 to the 2/3 power. So again, the 3 is on the bottom, so that's my root. cube root of 27. And then that whole thing has been raised to the power on top is 2. And so then we could evaluate. The cube root of 27 is 3. And then that whole thing is squared. 3 squared is 9. Okay, now we need to be comfortable moving back and forth between the fraction exponents and their evaluatable equivalent. All right, so we got to be able to go between the radical and the exponent and the fractional exponent. We need to be able to move back and forth with those. Okay, now let's go ahead and look at the power property of equality. Okay, so there's a statement here, and I'm going to pull it down. So b to the x equals b to the y if and only if x and y are equal. Okay, so some base raised to a power equals some other base raised to a power if and only if those powers are equal. Okay, so here's us solving some equations. Okay, so 5 to the x equals 5 cubed. Well, that's only true if x equals 3, right? So we got the bases the same, which this one gave us the bases the same to start with, but bases are the same, and so we can work with the exponents. Here's the other example they gave us. 4 to the n equals 4 to the 1/2 only when n equals 1/2. Okay, now that seems a little simple, but what we'll run into is what happens when the bases are not the same, and so we'll have to try to change the bases, right? So here we go. 6 to the x equals 216. Well, that's only true when the base on both sides of the equal sign is 6. Okay, so this is already 6 to the x. So how can I rewrite 216 with a base of 6? Well, I happen to know that 6 cubed is 216. And so x equals 3. Okay, now this all started because we got this and this to be the same base. And so that's kind of the thing that we're going to have to do. So if I'm looking at this other example over here, I need the 5 and the 25 to be the same base. Kind of makes sense that 25 can be rewritten as 5 squared. Okay, but now 5 squared is being raised to the x minus 1 power. Okay, so notice the little power to a power that's happening over here. So bases are the same. There's a 1 right there that I don't see, but I know it's there. So 2 times x minus 1 has to equal 1, and then we would solve this. All right, so 2x minus 2 equals 1, 2x equals 3. And so for this problem, x equaled 3/2 would be my answer. All right, now this is something we'll have to play with. It's going to take a good bit of practice. I just wanted to introduce it now, and we'll play with it in class.